Welcome to This Explainer. Look, we're living in a moment where artificial intelligence is just fundamentally transforming how we work. It's everywhere, right? But along with those massive leaps forward in capability, we are quite literally opening doors to vulnerabilities that our traditional security frameworks just weren't built to handle. So today, we're cutting through the hype. We're going to systematically break down the unique cybersecurity risks introduced by AI, looking at the hard data, the real-world frameworks, and the actual threats coming with our new AI-driven reality. To do that, we'll be following a strict threat and defense structure today. We're going to start with the illusion of reliability and the risks hiding in AI-generated code, then move into adversarial attacks and the true cost of AI failure. Finally, we'll wrap up by looking at the defense frameworks and how we can actually restore trust with proper oversight. And this really all boils down to one incredibly provocative question. Can we actually trust AI with our cybersecurity? We are increasingly handing over the keys to our digital infrastructure to systems that are, by their very nature, probabilistic. So can we trust them to keep us secure as they scale up in these high-stakes environments? Let's dive into Section 1, the illusion of reliability. We really have to start by acknowledging the elephant in the room, the staggering productivity gains AI promises, which, honestly, often mask the underlying vulnerabilities. Just look at the metrics. When an empirical study shows that developers using an AI coding assistant like GitHub Copilot finish their tasks nearly 56% faster, well, every organization on the planet takes notice. It's a massive boost. It lowers skill barriers, it gets products to market faster, and it perfectly illustrates why AI adoption is skyrocketing. But as we all know, speed without safety is a total recipe for disaster.
Because here is the 5 nines reliability problem. At first glance, a model performing at near-perfect accuracy looks pretty much flawless, but even a vanishingly small failure rate of 0.0559% translates to over 500 failures per million queries. If you're deploying this in safety-critical settings or processing millions of automated cybersecurity requests, a fraction of a percent error rate means hundreds of tangible, potentially catastrophic failures.
Now, what's really fascinating here is the data from a recent Workday study. It exposes this massive AI trust gap. Look at the disconnect. You've got 62% of leaders super eager to adopt AI, and 70% know humans need to stay in the loop. Yet, only 22% of employees report actually receiving any guidelines on responsible and secure AI use from their companies. We are basically rushing to deploy this tech without giving the guardrails to the people actually using it every single day. Which brings us to Section 2. Risks in AI-generated code. If the folks using AI don't have the safety guidelines, what exactly happens to the code they're generating? Well, get this. A recent report from the Center for Security and Emerging Technology found that almost half, yes, 50% of AI-generated code snippets contain impactful bugs that could be maliciously exploited. So, as organizations lean heavily on AI for that massive productivity boost, they are simultaneously injecting potential zero-day vulnerabilities straight into their software supply chains. To understand why this is happening, we really have to contrast traditional software risks with the highly complex, uniquely socio-technical risks of AI systems, just as NIST outlines. Traditional software is, generally static. You write it, test it for known failure modes, and it behaves. AI is a whole different beast. The models are inscrutable, they suffer from concept drift when the real world changes. You can't just use standard testing protocols because AI acts on statistical emergent properties. It's like trying to nail jelly to a wall. Moving on to Section 3, adversarial attacks and manipulation. Because beyond just generating insecure code, the AI models themselves are massive targets for bad actors. The attack surface isn't just about hacking a server anymore. It's about hacking the model's actual logic. Attackers can compromise systems through incredibly sneaky techniques, like data poisoning, where they subtly alter the training data so the AI learns the wrong ground truth. Or they use malicious nudging to manipulate the algorithmic information presented to human decision-makers. Preventing this requires entirely new physical and cybersecurity protocols to block unauthorized access. Okay, Section 4, the cost of AI failure. Let's ground all this theory in reality, because these aren't just fun, abstract academic concepts. What actually happens when AI fails in high-stakes environments? You've probably heard about this wild case where high court judges referred lawyers to regulators over AI-generated fake citations. This recent crisis with AI hallucinations proves exactly why blindly trusting a large language model is a terrible idea. You aren't just risking a minor glitch, you are risking severe reputational damage, regulatory sanctions, and a total loss of client trust.
And as this breakdown from NIST so perfectly illustrates, unchecked AI risks have a massive blast radius. They don't just cause operational hiccups, they scale up to harm individual civil liberties, completely tank organizational reputations, and can even cascade into interconnected global ecosystems like financial markets or supply chains. The stakes are literally that high. All right, let's take a breath. Section 5, Frameworks for AI Defense. Having established these stark threats, let's pivot to some good news. The defensive framework's actually designed to mitigate these exact failures. We can use the NIST AI Risk Management Framework to really visualize the building blocks of a solid defense. It's all about ensuring systems are valid, safe, secure, and transparent. Notice how being valid and reliable is the foundation. But on top of that, you need explainability and privacy. If an AI system is secure but totally unexplainable in how it makes decisions, well, it's not trustworthy. All these characteristics have to be balanced based on the context of the deployment.
So how do we build that into an actionable defense? You utilize the 4 core functions of the NIST framework to systematically triage those vulnerabilities. First, you govern by setting a safety-first culture. Then, you map out the specific context and potential harms. Third, you rigorously measure the system. And finally, you manage, prioritizing the risks and deciding how to respond, even if that means pulling the plug on the deployment altogether. But here is the kicker. Even after you do all of that, you are still going to have what's called residual risk. You can never eliminate 100% of the risk in an AI system. Organizations absolutely must rigorously document this remaining residual risk so end users are fully aware of potential negative impacts before they even interact with the system. And while frameworks like NIST are voluntary, on the legislative side, things like the EU AI Act are drawing hard lines in the sand. It establishes a regulatory shield that strictly prohibits these specific high-risk AI deployments, like subliminal manipulation or untargeted facial recognition scraping, to protect citizens from systemic harm. This is policymakers enforcing an absolute ceiling on risk tolerance. Finally, Section 6, Restoring Trust with Oversight. We know the risks, we have the frameworks, but how do we implement the operational and technical oversight to safely use AI moving forward? Well, on the technical front, we're seeing incredible safeguards emerge, like zero-knowledge machine learning, or ZKML. This is a total game changer. It's a privacy-enhancing technology that allows a system to mathematically prove an OI decision was computed faithfully, all without exposing the client's sensitive data or leaking the provider's intellectual property. It brings actual cryptographic proof into a space that currently relies way too much on blind trust. But even with fancy cryptography, we can't forget about HITL, human in the loop. Yes, it introduces costs and scalability bottlenecks, but it remains an absolutely essential safety net. Remember, 70% of leaders agree human intervention is necessary. Having a human expert review outputs is still the most effective way to catch those weird edge cases before they cause real-world harm. There's a quote that just perfectly encapsulates the core risk we're facing. The architecture of knowledge as we have known it until now is under attack. Actually, I'm scared. AI outputs are based on statistics, not verification. When models generate beautifully written code or data that is entirely fabricated, it erodes our basic systems of truth, making rigorous security frameworks absolutely non-negotiable. So I want to leave you with a final thought to consider regarding your own organization's software supply chain and AI strategy. Knowing the invisible vulnerabilities in your AI tools, are you preparing to govern the risks, or are you just waiting to manage the fallout? The risks of AI are hidden and complex, for sure, but they are manageable if you proactively apply the right frameworks. Thank you so much for joining me for this explainer, and I highly encourage you to go look at how your own teams are mapping and measuring their AI deployments today.